So this is part 2 of solving equations. This video is going to focus only on how do we solve equations when there's variables on both sides of the equals. So the first portion of this was what happens when you have distributive property or like terms. This one's going to have variables on both sides of the equals. Part 3 will be an algebra video, which is going to encompass everything in one whole entire video. So what we've got now is, and we'll go ahead and share screen here, and we'll go through this one pretty quick because we're not going to need to spend a lot of time because it's just one idea. If you recall in the last video, you could combine like terms if they were on the same side of the equals. Well, in this section, you're going to have a 5x and a 6x, but they're on opposite sides of the equals. So we cannot combine them right now. You cannot combine things through the equal sign. But what we can do is we can move it. We can make it disappear from one side, basically become nothing, and move to the other side. What I would recommend is always take the smaller one and try and move that. Now you can move either one. So I can move the 5x or I can move the 6x. All right, but typically we want to move the smaller one, especially in this case because the x's are already on the right side with nothing else. So I'm going to move this 5x. Well, in order to do so, I need to make this become nothing. Well, the opposite of 5x is to subtract 5x, because if I have 5 and I subtract 5, all of the x's in that spot are gone. Well, remember, I have to maintain balance. So if I subtract 5x here so that these cancel, on the other side of the equals, I also have to subtract 5x. Well, when I do that, I have 6x minus 5x, and that's 1x. And then I'm going to bring the equals down, and I'm going to bring down the 5. Well, this particular example, it worked out great because when I subtracted the 5x to move it to the other side, all of a sudden, x was alone, and this became a very simple equation. But they're not all going to be like that. So example 2 is really what an equation with variables on both sides will look like. So I'm going to go ahead and put my barrier down the middle here. And I have a 5y plus 8 and a 7y plus 6. I have a y on the left side of the equals and on the right side. So I'm going to have to move one of those. Like I said before, we're going to typically want to move the smaller one. So I'm going to move the 5y. Just like we did in the first example, I'm going to undo it with a negative 5y. So they'll cancel out. Whatever you do to one side, you have to do the same thing to the other side of the equal. So I'm going to put a minus 5y right underneath the 7. Well, let's just simplify and bring everything down. 7y minus 5y is going to give me 2y. I'm going to bring down the equals. I'm going to bring down the plus 6. And I'm going to bring down the 8. At this point, you should be looking at this and it should look very familiar to you because right now I have a simple two-step equation. To get the 2y alone, I still need to undo the addition and subtraction first. So I'm going to subtract 6 to both sides. 8 minus 6 is 2. Bring down the equals, bring down the 2y, and the 6's cancel out. And if I have a 2 touching with the y, that means multiply, the opposite of which is divide. How many times does 2 go into 2? Answer is y equals 1. So you have variables on both sides, and I need to pick one of those to cancel out and move to the other side. Now, in this particular section of IXL, they're also going to throw in an occasional problem that has decimals to it. Now, the decimal problems are not going to be too crazy to do, but I do want to show you a little trick that will help you solve problems with decimals of all kinds. In this particular problem, the biggest I have is 1 digit behind the decimal place. Now, if you had 2 digits or 3 digits, you would just increase the power of 10 that we're going to use. If I want to move a decimal place one time, because that's really what I want to do here, I want to move these decimals one time, I am going to take this entire problem and I'm going to multiply it by 10. Because if you multiply by 10, you're going to get to move the decimal place over one value. If I need to move the decimal over two values so that it's gone, I'll multiply by 100. And if I need to move it 3 times, I'll multiply by 1,000. And you have to maintain balance throughout the problem. Well, when this decimal moves over 1, 1.3 times 10 is going to make 13x equals 10.5 times 10. I move the decimal once, so that becomes 105. And then 2.3 times 10, I'm going to move the decimal once, and that's going to become 23. Now we need to move the x's to one side. And I have said typically to move the smaller one, which is fine. But the x over here on the left is almost alone. So this is going to be a rare occasion where I actually want to move the bigger one, because I want to move it to the side that only has the x. And you'll see what happens on the next step. When the 23x's cancel out, I'm left with negative 10x equals 105. If I had moved the 13, I would not have something on both sides of the equals. Well, let's go ahead and divide by negative 10. Remember, if it's a negative 10 touching the x, I have to make sure I divide by that. And there's a couple of things I can do on this one. I understand that there's one negative, so I'm going to say, okay, that's going to be a negative answer. And 105 divided by 10 is 10.5. I could have kept the fraction answer, and I could have said 105 over negative 10. And then I would just have to reduce that. And I would have to make sure to find something that goes into both, which would be 5. So I'm going to divide that by 5. So that's 21 over negative 2. And if I was to put that in the calculator, I would get the same answer here. You're not going to have very many decimal answers at all, so don't worry too much about that. But this is a good example for you to see. Let me go ahead and give you one here to try it yourself. So we're going to give you variables on both sides. And let's go ahead and say that it's 5x minus 7 equals, and let's make it 7x minus 13. So go ahead and take a moment and pause this. Remember to move the x's to one side. And then when you're done, go ahead and resume the video to see it worked out. Now that we're back, let's see how you did. I'm going to take the 5x and I'm going to move that to the other side because it's the smaller one. So in order to cancel it out, I'm going to subtract 5x and I'm going to subtract 5x. If the thing I'm moving is already negative, I would just undo it with a positive. So the 5x's cancel out. 7x minus 5x is 2x. Bring the equals straight down. Bring the negative 7 straight down. Bring the negative 13 straight down. This is now a two-step equation. So to get the 2x alone, I'm going to start by adding 13 because I want to undo the minus 13. A negative 7 and a positive 13 is going to give me 6. Bring down the equals and bring down the 2x. Divide by 2 on both sides, and I'm going to get x equals 3 for my answer. So equations with variables on both sides, you're going to find one that you're going to move to the other side, and then you should have a simple two-step equation from there. The next section for the solving equations, we're going to start to mix it all together, and I'm going to give you access to the video from the high school algebra class. You may or may not need that because you might be able to pull from the last 2 videos in order to put it all together. Again, if you've got questions, reach out to me or bring them to the next class. Have a great day, and I will talk to you guys later.